Hi, good day, and welcome to part 7 of the June 2021 Maths Crash Course. All right, now today we're going to be doing a few questions on sequences. Now, I already did a complete tutorial on sequences. All you need to do is go on YouTube, type in iLoveLessons sequences, and it will be this green video with the sheep on it. In that video, I have done all the theory needed to do questions like these, and I've done some of the harder questions that came for CXC in that video. So this video is going to assume that you watched that video, because I'm going to be referring to formulas, and of course I'm not going to be doing back the theory because all the hard work was already done in the mentioned video. Alright guys, so let's get started. Here we have a pattern here, right? It's a pretty straightforward scenario. Pattern 1 has how much blocks? 1, 2, 3, 4, 5. And you notice that they have the 5 blocks here. So, 1 second, I just want to make sure everything is recording. Great. In pattern 2, if you count up the amount of blocks, you have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is exactly what they have here. The first pattern has 5 blocks. The second pattern has 9. The third pattern, let's just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they want you to complete the table. Now, for pattern number 4 and pattern number 5, we can simply just count up all the blocks. And of course, you could do it like that. But you can save time in the exam by realizing that there's a pattern. Pattern 1, pattern 2, pattern 3, pattern 4, and pattern 5 will all be increasing by a certain amount. If you take 9 and minus the number just behind, 9 minus 5 is how much? It will be 4. If you take 13 and minus the number just before, 13 minus 9 is 4. It means that all of these numbers are just increasing by 4. You call this type of pattern an arithmetic progression. So it's an arithmetic progression, which was mentioned in the green video with the sheep on it. So I don't think it's necessary we need to count up all of these blocks. It's just that if it's always increasing by 4, 13 plus 4 is 17, 17 plus 4 is 21. It's as simple as that. Now they're asking us for pattern number 12 in part C. Obviously, I'm not going to go pattern 6, pattern 7, and add 3, 8, 9, 10, 11. I'm not going to waste time doing that. Instead, I can use the arithmetic progression formula, which is, where do I have space? Let me put it up here. Tn is equal to A plus n minus 1 multiplied by d. Tn is the 12th, well, is the term we are trying to find. So we are trying to find the 12th term. That's how you write it. T12, pattern number 12. A is the first value in the series, A. So the first value in the series was 5 plus n minus 1. Remember, n represents the actual value, the value of the number of the sequence itself. We're trying to find the 12th pattern. So n is 12. So it's 12 minus 1, and d is your common difference. The common difference is how much the numbers are increasing by. To get the common difference, you just take the number in front and minus the number just behind. And we knew from before we got 4. So all we need to do is work this out, and we will get the 12th, the amount of blocks in the 12th pattern. 5 plus, well, 12 minus 1 is 11, and you multiply it by 4. Let's see how that goes. I'm going to multiply the 11 by 4 first. 11 by 4 is obviously 44, and then add 5. We get 49. So the amount of blocks in the 12th pattern should be 49. And you know it's an arithmetic progression because every time you take the number in front and minus the value behind, every time you do it, you always get the same number. In this case, that same number happens to be number 4, better known as your common difference. Alright, so that was a pretty easy one. Excuse me. Alright, in B, it's about the number of sticks, and I have a feeling this one is going to be just as easy as the one above. In the space below, they want me to draw the 4th pattern. Now, I'm not going to waste too much time here. You could see the pattern here. They just added an extra 2 horizontal and 1 vertical. So if this is the 3rd pattern, to make the 4th pattern, I'm just going to add in this part here. But I'm already supposed to draw the 4th pattern in the space provided here. So that's it for part A. For part B, they want you to complete the table. Now the number of sticks in the first pattern is 4. Look, they have it here. In the first pattern, they have 4. In the second pattern, they have 7. 1, 2, 3, 4, 5, 6, 7. In the third pattern, they have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, and in the 4th pattern, we can count it up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. They want a 5th one here. Now, if I make the 5th one here and add up all the sticks, I would obviously get 16. You realize that it's always increasing by 3. If I take 7 and minus the number just behind, I get 3. If I take 10 and minus the number just behind, 10 minus 7, for all of them, if I do that, I take the number minus the one just behind, I'm always getting 3. So this is an arithmetic progression again. And they want us to find the amount of sticks in the 10th value. So going back to the same formula I just used, a plus n minus 1, by d, we want to find the 10th term, T10. A is the value in the first pattern, so that's 4, plus, we're trying to find the 10th term, so it's 10 minus 1, so n is 10, and the common difference, we just worked it out, it was 3. Work this out quickly. 10 minus 1 is 9 by 3, so we say 9 by 3 is 27, plus 4, that will give us 31. And that's the answer for part C. So both of these questions, the one above and the one below, were both arithmetic progressions. Alright, so here's, well, nobody cares anymore. Alright, so, alright, C. They want us to draw the 4th pattern here. Now, I'm going to assume that you realize that to move from here to here, they just added 1 dot here, 1 dot here, and 2 dots here. And they keep doing that. So to get the 4th pattern, I'm not going to draw it down here. I'm just a little lazy to do it. You're going to add a block, not a block, a dot here, and 2 dots here. This drawing will go over here. Right, so that's all they wanted you to do. To draw pattern 4. It's a real simple pattern, right? They want you to complete the table. The first pattern has 8. 1, 2, 3, 4, 5, 6, 7, 8. The second one has 12. The third one, well, let's just make sure that's the black ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right, it did have 16. So the third one had 16. They're asking you to figure out the 4th and 5th. Now I have a good feeling this is going to be an AP again. If you take the 12 and minus the number behind, we get 4. If you take the 16 and minus the number before, you will get 4. So to find, and but this one is simple. It's not like they're asking us for the 22nd term or the 100th term. You realize that you're just what? Increasing by 4. So the next one will be 20 and the next one will be 24. And yes, the questions do come easy like this in CXC sometimes. Okay? Alright, give me a few seconds. Let's drink some tea here. Alright. D. They want you to find the nth, sorry, they are telling you the nth term of a sequence is 2n plus n minus 1. Plus 2, yeah, n minus 1. They want you to find the 10th term. So they're trying to say Tn is equal to 2n plus 2n minus 1. And they want you to find T10. So you're replacing n with 10. It's as simple as this. You say 2 to the power 10 plus 10 minus 1. 2 to the power 10 plus, and this is, well, 10 minus 1 is 9. Let's work this out on our calculator. 2, well, the EXP button here, you just have to press, well, no, sorry. 2, the power button is the YX button here. To the power 10 plus 2, the YX button, 9. And that's our answer there. 1536. Alright, so that's our answer for D. As simple as that. This one here, the nth term of a different sequence is this. So let me zoom in here a little bit. Right. So it's 4 2n plus 2n minus 1. They want you to circle the expression that's equal to this. Now this is really an indices questions in disguise. Let me just refresh your memory on a little bit of indices here. Let's go to the scrap paper here. If I have x to the power a multiply by x to the power b, you notice the bases are the same, and if there's a multiply, that means you have an excuse to add the powers. Multiply means you can add the powers provided the bases are the same. So you will get a plus b. Let's put some numbers to that. Let's say I had 2 to the power 6 multiply by 2 to the power 4. The 2 and the 2 is the same. The bases are the same. The bases are the big numbers. And there's a multiply here. Now for this to work, here has to be the same as here. If here's 2, here has to be 2. If here's x, here has to be x. This will be 2 to the power 10. Because multiply means you have permission to add the powers. Not multiply the powers, add the powers. So if I have 4 multiplied by 2 to the power n minus 1, well, we can't, at first glance, it seems we cannot do anything because here's 4 and here's 2. I know when you have 4, the power is automatically 1. So you might be tempted to add the powers. But to add the powers, the bases must be the same. But let's scratch off the 1 there. Isn't 4 the same thing as 2 squared? 4 is the exact same thing as what? 2 squared. Okay? So now if I change it to 2 squared, the bases are now the same. So now I have permission to add the powers. So I put the 2 and I add the powers. 2 plus n minus 1. This can be simplified because 2 minus 1 is 1 and then I have plus n here. Alright, so knowing that piece of information now, let's move back to here. What's going to happen? This 4, I need to zoom in here. This 4, I can replace it with 2 squared. And inside the brackets, I have 2n plus 2n minus 1. Now, between here and here, there's a secret multiplier. So that means I'm going to be multiplying these two and then these two. But since all of them have the same base, when I'm multiplying, I have permission to add the powers. So 2 multiplied by 2n. But here what? Let me expand it up. I have to multiply everyone inside here by 2n. So I have 2 squared, and I'm going to multiply him by what? 2n plus the 2 squared also has to multiply what? The 2n minus 1. Multiply means you have permission to add the powers provided the bases are the same. So for this one, since it here has a 2 and here has a 2, you say 2 plus n. So that's just 2 plus n. And over here is 2, and we're going to add the powers. 2 plus n minus 1. And we just saw that the 2 and the minus 1 will add up to give you 1 plus n. Isn't it this one here? This is the one we have to circle. I mean, I have 2 plus n, but 2 plus n is the same thing as n plus 2. And 1 plus n is the same thing as what? N plus 1. Alright, so this is the one you would have to circle in the exam. Alright, sorry about the little mess there, but I have limited space to work. Alright guys, believe it or not, part 7 was a pretty short one compared to the rest. But take my advice guys, please watch this video here. It has some really good pieces of information and some of the harder sequences question that will come, but that can come, sorry, for the CXC exam. Okay guys, so and of course I just wanted to point out that if you're looking for all my videos, all you have to do is just type iLoveLessons, right? And a lot of my videos will come up, but you can just click on the icon here and go to videos, and you will see the amount of videos I have available for maths. I have some for integrated science, I have for maths, I have solutions. Check it out guys, it's free. It's obviously it's on YouTube, it's free. So, and don't forget to share and subscribe and comment. Take care guys and have a good one.